Today I'm going to take you through having a little play with audio data in Python, obviously. This is the first time I've played with AI-generated images, and it took me quite a few attempts because it kept giving the snake arms. Eventually got there with no arms on the snake. So a little bit about me. I'm currently a data scientist at a company called Raytheon UK. Previously worked in other government bits, and I taught myself Python about 10 years ago when I worked for a marketing intelligence company. I had some amazing friends who helped me along the way. And in the last 10 years, I've grown my Python knowledge, and now I do a lot of machine learning and AI. I'm also a servant to two cats, which you can see there. Ozzy is the black fluffy cat, and Izzy is the other cat. Ozzy likes to come and remind me that I need to have lunch. That's his "you need to stop working for a bit" face. I'm also a gamer, crafty in the sense that I make things, not that I am sneaky. And then in my free time, I drive ambulances around London, because why not? So let's get into it. So audio data, why would we want to use it? So these are some of the questions that we may want to have answered. So what song is playing? What language is being spoken? Can we identify who the speaker is? I'm sat in my flat and I hear a rumbling. Is it the truck outside, or am I hungry and I've forgotten to eat my lunch? This isn't an exhaustive list. I'm sure you can come up with lots of others. The reason I fell into audio data was I was tasked with a challenge of identifying a whole wealth of different languages in recordings. It was about 45 different languages they wanted identifying. And this was my first foray into deep learning and machine learning as a whole, really. So the what languages, that was my entry into this. So there's quite a few things about audio data that you may not necessarily want to be considering for other things. So we've got sampling. So we hear sound. The computer doesn't necessarily understand that the same way we do. So sampling is taking that sort of sound we hear and making it into a form that the computer understands. And it does this at regular intervals, and that's what's called the sampling rate. I don't know your background. It's going to get a little bit fizzicky, okay? With the amplitude, so when the sound, like the speakers in here, it changes the pressure and it moves through the air. And then our ears pick it up and magic happens, and then you can understand what I'm saying, hopefully. So the amplitude is that sort of pressure level. So in here, it's going to be quite low. If you go and sit in a rock concert, like I saw Linkin Park a few weeks ago, that's going to be a bit louder. Yeah? You then also have the bit depth, which kind of determines the precision of the amplitude value. And you may be more interested in some of these values more than others, but we'll go through a little bit of how you can pull that out of the audio file. That waveform there is for a barking dog, and that's going to be my running example through the entirety of this. So keep in mind a barking dog. So there's quite a few libraries out there. The one that I find most useful, and the one that I've used primarily through all of this, is Librosa. And then obviously there's SciPy as well, that has some of the same functionalities, but I find Librosa takes you a little bit more, gives you a little bit more features to play with. There's also sound file. That's more around loading your audio file, and then you can change it into different things, convert it from a .wav to a .mp3, for example. And then the last four, I won't go into too much detail, but they're more specific. So Torch Audio is very particular to using PyTorch, but you often, when I've used it in conjunction with Librosa and pass it through. All the examples that I'm going to show you today are through Librosa. There are a couple of SciPy ones as well. I'm not sponsored, by the way, and I might be saying that differently to how some people say it. I apologize. I hope you can understand that. Okay, so first we're going to get the file. We're going to find what file we want, and we're going to load it. I've done it with pictures and not gone through the Jupyter Notebook because I have had nightmares of the notebook going wrong. I will share the notebook on the website later on. So here we're just taking librosa.load for the audio file, so the barking dog, and we are taking the sampling rate, which we mentioned earlier, and then there's also the time series representation, and we're calling that an array. You can call that anything you want. You don't have to use array. And then from there, we're going to calculate the sampling rate, amplitude, and bit depth. And here we do use a little bit of NumPy, or NumPy, however you say it. So the sampling rate is just literally taken from that load, and then the amplitude and bit depth is calculated. You've taken the array and you've taken the maximum and minimum, and that gives you the amplitude range. And then the bit depth comes from the itemize there. In my forays into language identification, the sample rate was kind of useful, but only so I could get fun pictures. And one of these pictures is the waveform. Apologies, this is repeated. You have seen this waveform before. It's still the barking dog. And that picture is quite small, but that's just using matplotlib to display that waveform there. And that just shows the amplitude as plotted against time. Maybe we want to have a look at the frequency. And from this, we can use SciPy and a part of SciPy that's called Spectrum. And that just takes the Fourier transform. Anyone else who's done maths or physics or anything mathsy might be having like chills. I'm not going to go into any more Fourier transforms. It's there. YouTube still recommends videos explaining it, and it still gives me nightmares. But it does use Fourier transforms, and then you just plot it. And you can trim it down if you want to zoom in to a particular timestamp or a particular frequency, so you can make that bigger or smaller, more, what am I trying to say, like zoomed in on different parts. Now we get to the colorful ones. So we can get a spectrogram. So this one's using Librosa, which kind of does like the sort of the black to the orange. Barking dogs don't tend to make very colorful spectrograms, apparently. But if you put through some languages like French, German, anything, you do tend to get a little bit more variation. And if you put in a different speaker, you get a different one. You can also do the same with SciPy. And this gives you different colors. There are ways you can change the colors, but I won't go into that. You can have a look at the documentation yourself. It's in there. And this is just showing the power and the frequency in a different way. You can then use these to try and identify things. So you could feed it into a machine learning type model and try to figure out if it's a car horn or if it's a siren. One of the projects I've done at work was trying to identify if we could identify different sirens and if we could extract some of the sirens from the surrounding noise. It didn't go so well because the amount of data we had was really poor, and bad data in tends to lead to bad data coming out, as we all know. If you want more colors, we can go down the chromogram route. I haven't quite found a use for this one, but it's pretty, so I included it. This one is also from Libro, so this isn't available in SciPy, as far as I could find. So it has pitch against time on this one. And it looks kind of pretty, with some black holes in the middle, because black holes are fun. Little bit of maths now. I've gone really fast through this. Oh boy. Is using MEL spectrograms. So in a standard spectrogram, the frequency axis is more linear. So we can take this and do some fun logarithms with it to create the MEL frequency. And then it's plotted, and it's basically filtered into bins, and you pull it out. Tend to go between 40 and 80 for the number of MEL bins that you use. And when I've previously done this with language recognition, is the MEL spectrograms that we used for this. Almost turning the audio recognition side of it into like a picture, into an image classification thing for the computer. And it seemed to do quite well. And then from here, you could literally do anything. So like I've already mentioned, we can do language recognition, we could do speaker recognition, we can do all of those things that we mentioned at the beginning. Yeah, I've gone really fast through that. When I practiced it, it was like 10 minutes longer. Yeah, so thank you for listening. It was really last minute that I got asked to do this. So also thank you to EuroPython for letting me have a go. Yeah, you can follow me on Instagram. I'm also on LinkedIn. On LinkedIn is a link to my GitHub. And there's Ozzy saying bye. Sorry, so quick.
Thank you, Tamsin. So it's time for questions. If you have questions for the speaker, this is the time for you to ask.
We have loads of time.
We have a first question here.
Hello, thank you for your speech. I was wondering, when you have pre-processed your data, what do you usually use for models? Is it, you mentioned image models, but how about like time series models, for instance? Do you use those, or yeah, how do you work with the images afterwards? That's what I'm trying to ask.
So we've done a bit of a mix. It's mainly been taking the images, but we have used time series before. Haven't really noticed too much of a difference between the two. It's more of a who's doing it and how quickly we want it done, and what we're using on sort of the compute side, like how much power have we got. So yes, you can use time series. You don't necessarily have to go down even generating the MEL spectrograms. You can just take the numbers. Computers love numbers. So you just get a matrix from it. If you calculate those MEL I've lost words, but you get the numbers out instead in a massive matrix, then you feed that, and it's actually a little bit quicker on the learning side. On the recognition side, it's about the same.
Okay, thank you.
The next question, please.
Hi, thanks for the talk. You managed to have it live subtitled, and as you are doing audio jobs, can you describe your setup so that made that possible?
Absolutely. It's a setting in in PowerPoint, actually. If you go into Presenter, where you find the Presenter view, just beside that is subtitle options. And you can enable them, you can change the language, and you can change where they appear. So you can put them at the top, at the bottom, you can overlay them. I can show you the setup afterwards if you like.
We have a third question.
Yeah, thanks for an interesting presentation. Have you tried to do something similar with like near real time? Because this was recordings, and doing it near real time brings a lot of more problems to it.
Absolutely. I haven't personally. Everything I've done has been based on recordings. So when I was making sure that I was putting the right things on, there is a really good course on Hugging Face that will take you right from the basics all the way through. And if I remember correctly, there was a bit on there about doing near live recognition or using near live audio input. That's on Hugging Face. I think I still have it up on my browser. If you want to come up afterwards, I can share it with you.
Hello, thank you for your talk. I don't know if you pre-process the audio data before passing it to the models, if you lower the beats or something like that. For example, I am interested in voice recognition and diarization or identifying the speakers and so on. So, so I can. Okay, my intention is to be able to clean the noise behind the voice. So maybe you have some technique for that?
So denoising, I haven't done too much about. I have looked into it, and there are some packages around that would do that for you. In terms of pre-processing for the audio that I've used, it's mostly been standardizing the length and the sample rate and things like that that I've done in terms of pre-processing. For identifying speakers, did you say?
Yeah. Yes. Because you said at the beginning of the talk, you said something about identifying the speaker.
Yeah.
So how do you do that? Because
so
I cannot see the slides, so maybe you have put it in the slides, but I don't. I don't remember. Sorry.
I don't think it's all been quite high level, so I don't think I went into detail on speaker identification. For that, how I've done that previously has been a person of interest and identifying them from recordings, rather than having a microphone on and identifying person 1, 2, or 3. I know that there is code out there that will do that. Yeah. So that is my experience with speaker identification. And it's a lot easier with recordings to clean it up and keep having a go at it rather than doing it live. Sorry, I can't give you much more on that one.
Okay, we have another question there before the next one.
Hi, sorry.
Hi.
So first of all, amazing talk, thank you. It wasn't too short, don't worry.
Okay.
So basically what I wanted to know is about human emotions. And I wanted to ask you, have you ever worked with recognizing human emotions like anger, frustration, I don't know, because I'm working in a field where we want to identify the customer's mood basically, right? And so the question is this actually possible using these kind of approaches?
I think it would be possible. It's actually something that I want to do, and I asked my work if I was allowed to have a go at it, and they said that we didn't have the money for it at the moment. I would love to give it a go. I would probably go this route first, because this is how I've done this before, and that's what I'm familiar with, to see how well it would handle that. I suppose when you're emotional, the amplitude, frequency, and things of your voice does change. So from that, I would assume that this method would work.
Okay, thank you.
Hello, thank you for the talk. You mentioned in the beginning that your aim was to identify languages spoken in the audio. So can you share with us a little bit of what models did you use, what tools did you use?
So, trying to remember. So I use a lot. So initially I started using PyTorch, which worked quite well, but then I ended up moving away from that because it wasn't quite giving me the accuracy that I needed. So I ended up using Terrace. I ended up training my own model because of the languages that I needed. I found that a lot of the pre-made models at the time were very geared towards European, especially Western European languages, and what we were interested in at the time was more Eastern European, Middle Eastern, and African languages. And I spent about 2 weeks trying to collect a load of audio files from all sorts of different places in order to train my own model. Ended up using a neural network for that. Yeah, and as far as I'm aware, it's still working. Yes, I did. And probably now I would not train it from scratch. That was a newbie, let's give this a go and see what happens type thing. Now I'm a little bit older and wiser, and I probably would not subject myself to that again, and would probably just take a pre-made model and then adapt it a little bit, rather than sort of dragging myself through the mud like I did. It was fun, though, in a weird, masochistic kind of way.
Do you have more questions? I can't see any more questions. I think you are all good for now. Thank you, Tamsin Fuller, for your amazing session. If
Thank you
have
for
more
coming.
questions,